Hello and welcome to TelecomTV. We are here at the SDN NFV World Congress in the Netherlands, in The Hague, and I'm talking with Diego Lopez, Senior Technology Expert at Telefonica. Diego, great to see you again. We meet all over the place.
Yeah.
Today's another one.
This is part of the fun, isn't it?
It is. And next to you, Andrew Coward, CEO, Lumina Networks. Andrew, we also meet all over the world, and here we are again. So welcome to you both. Great to see you. We're going to talk something on the lines of cloud native and why it's important and so on. And I'd like to begin with you, Diego, if I might. One of the things that one's hearing around here, and one you're certainly hearing outside an auditorium like this, is have CSPs been spending too long on virtualization? Is it now time to look beyond NFV?
Well, it's time to make the technology a little bit more mature to move a step forward. I mean, I don't think that cloud native means something that is disruptive with respect to the original NFV concepts. It's the natural consequence of how NFV was conceived at the beginning, and is a part of this natural evolution. So yes, it's the moment of starting thinking about it and starting some deployments and some initial moves in that direction, definitely, yes.
Okay, Andrew, your point of view on this?
Yeah, I think a lot of vendors were told by the carrier community very early on, we want NFV, but we want it in containers. We want it cloud native. And a lot of vendors simply weren't ready, because actually it turns out it's quite hard to get the data plane into containers and actually have it deliver performance at the same rate as a traditional piece of vendor hardware. So it's taking that transition time. But I think from the outset, it was definitely a destination, probably before we had this, cloud native was a real term. Right?
So staying with the technologies, are these technologies developed by and for the cloud providers really suitable for CSPs, or do they need adaptation? Diego?
We need certain degree of adaptation depending on the plane we're talking about. I would say that in the control plane, the typical applications in the control plane are precisely control applications, and they are something that belong, let's say, to the known territories in how the principles around cloud nativeness can be used. In other cases, for example, we're thinking about monitoring. Probably we need, taking into account the nature of the monitoring data and the flows of data, etc., they need some adaptation. And for sure, in the data plane, as Andrew was saying before, data plane is extremely challenging. I'm optimistic about that. The adaptation is feasible, but it will require time because it's tricky.
You're nodding in agreement, Andrew.
Yeah, and so I mean, for us, using Open Daylight as the basis for our products, it adapts very well into container-based architecture, into cloud native, but it's not touching the data plane.
Right.
So for us it scales, and if you think about web applications, they scale very well, they're designed in that environment. But if you're running firewall rules in a data plane and that's where you've got to execute, then it's harder to get that performance level up. Now that's happening, but it's just a question of how quickly is it ready for that. But I want to kind of raise a slightly different point on the benefits.
You can raise anything you like within reason.
Right. Which is...
We haven't got any flags apart from that.
Which is that the benefits that will come from having container-based architectures in the cloud is that you can scale one element versus another. So that plays very well to the control plane. So if, for example, God forbid your network goes down and it all comes back up again at the same time and you've got to completely reconfigure your network in real time, you're going to want to have to put a lot more compute into that and have it scale in one dimension and then scale back. And that's the beauty of this architecture. Now that should play out in the data plane too. So let's just say, for example, you have a denial of service attack hit your network. You'll want to scale the response to that very, very quickly and consume compute resources, and then when the threat dies down, you back out. So some very real benefits that come from making these applications in cloud native and containerized and so on, that we're only beginning to see the benefits of it, and that's really where carriers will take advantage as the applications migrate.
And so under those circumstances, you would need a burst, in other words. It's bursty
Right.
sort of stuff, and then up there, and then completed, and then gone.
Right.
Yeah.
And probably think it's something that is some of these crazy ideas that we have been discussing with some colleagues in the past is that we are used at in general in the network and in particular in the data plane, that everything is a succession of steps. You have first whatever the node, afterwards you have another node, and we talk about service chains. In some cases, if we are able to scale up to to scale this or adapt these mechanisms into the data plane, probably we should start thinking about different architectures in which we not only have chains, but we can have trees or other structures, other kind of topologies, not network topologies, of processing topologies. And this is something that it is worth exploring. And probably we should start thinking in other terms, because we could take advantage precisely of these properties Andrew was mentioning about the cloud native environment, about scaling independently from the other components, etc.
Well, and that's playing out with the MEC, with edge compute. So we think about edge compute saying, well, I'm going to move my applications closer to the user for low latency and for other reasons. Well, you don't have to move the whole application. Once it's split, you might move one piece of it much closer to the customer and have the other piece in the back end and scale that, the edge piece out. And that becomes interesting. That plays exactly into that kind of different way of thinking, different architecture to the way we're currently thinking about it. So it's no longer monolithic. Here's my firewall, it's just going to be here, or here's my SDN controller, it's just here. It's now spread out and doing different things in different places under the same control.
I'm going to ask you what is probably a simplistic question, because I wrote it, and also simplistic.
Those are the worst questions,
Probably simplistic in as far as the answer I think is self-evident, but I want to cover it before we move on, which is this. Looking forward, not that far, a couple of years or so, whatever, I take it we're looking at a hybrid legacy / NFV / cloud native network. That's going to be there. How is it going to be managed? I'd like to begin by asking you, from Telefonica, how is it going to be managed?
With a lot of care. Now, seriously, this is a situation that if you're running a widespread, extremely pervasive infrastructure like networks are today, is something that you have to face in the moment you start any kind of transformation, change, whatever. It's something that you had to live with the idea that in the moment you introduce a new technology, a new way of thinking, you had to live with the other one, probably, or the other one or the other ones for years or decades. And this is something that is going to happen here and in our plans and in our commitments for example, network orchestration and understanding or making abstractions of our networks is something that is always this idea that you have to take into account the PNFs, the physical functions, the VNFs, the virtual functions, and very likely whatever comes after that is cloud native. So yes, this is part of the game, and we are aware of that. And that will not translate precisely in an extremely simply and lean network, but that's life.
Absolutely.
Well, and that's exactly why projects like Open Daylight exist, to abstract the business logic and what you want. Yeah. And so the business logic doesn't care. Is this a physical legacy device? Is it a virtual machine? Is it a container? The business logic stays the same. It's up to things like Open Daylight to help translate that into whatever it is that you need to deploy and to get to that hybrid world.
So we know where we're going to be starting from, as it were. We're going to find ourselves in the middle of. Diego, again, from a CSP's point of view, Telefonica's point of view, is cloud native sufficiently clearly defined in a networking environment? I know it's an ongoing process, but is it sufficiently defined, and does it need to be further defined?
I think that we still need to refine some concepts, especially when it comes to the data plane. We have, I would say, to put it in a few words, we have an idea where we want to get, but we don't have a completely clear, sharp view of how it would look in the moment we get there. So we need still to think, experiment, and find the best solutions for this.
Thank you. Andrew, you have spoken to me in the past about the journey to cloud native in a very Zen-like way, very philosophical viewpoint, in which you say it's a journey as much as a destination. Right, so expound on that, will you? What do you mean by this?
Well, because we're already doing things that are cloud native, right? and applications are already built that way and deployed that way, but we haven't got to 100%, and we probably never will run to 100% complete. So on this journey, the infrastructure becomes more containerized, the applications become more containerized, the data plane becomes more containerized, and we kind of move down that path. And as edge compute comes out, then you'll naturally want to put that infrastructure in place from day one as you roll that out. So will we ever get to the point where just everything runs in the cloud and we don't even think about it? Well, maybe not, right? There's always going to be things that are there, right? I mean, I don't know, you're still running ISDN probably in Telefónica's network somewhere.
ISDN, I think not,
okay.
But ATM, yes.
ATM, yes. Well, there you go.
There you go. Indeed. Okay, let's bring things to an end. We're witchering on a bit here, at least I am. We need to bring things to a close down. But looking forward, I want to finish on open source. It's a given with what you've been talking about, open daylight and so on, that open source is massively important. How important is it now, looking at it from where we are with the knowledge we now have, and how important is it going to be in the future? Or do you think we're going to find entire areas of open source with other proprietary stuff bolted on, which could make life easier or more difficult?
I mean, when it comes to open source, I think that this is that we have reached we reached some time ago a point of no return. I mean, the general industry has got used to that, and is a so powerful tool that nobody, even those who are extremely interested in having everything proprietary because of whatever the commercial reasons or whatever, would not be willing to stop using a so powerful tool for preparing even their commercial non-proprietary solutions. And open source is a new way of collaborating, it's a new way of showing by example, it's a new way of, I used to talk very often about demonstrative deliverables as well, that are not only normative or whatever, it's something that, look, here, it works, I'll show you. And I think that this is something that is going to continue even more in the future. That would not preclude, on the other hand, the possibility that somebody that comes with a extremely brilliant idea that they don't want, and they believe they're going to take a high benefit from it, they can try to exploit it, which is perfectly legitimate and is part of the game. And I think that this is going to be part of the ecosystem for the foreseeable times.
Right.
Andrew.
And we see, well, so just look at the underpinnings of this. Kubernetes,
Yes.
OpenStack,
Yeah.
Linux,
Yeah.
Open Daylight.
Yeah.
So notice none of those had data plane components in it, right? So that's the question really,
Yes.
is when does that happen? And to Diego's point, there is plenty of opportunity for proprietary vendors to add value in this by doing something very unique. A unique routing engine, for example, a unique way of processing packets for a firewall, or all of those things will exist and healthily coexist, but they have to slot into this ecosystem. So what we're losing in a good way from this is this kind of vertically integrated kind of mainframe world where one vendor controls everything from end to end, to one where they have to fit in this framework. So now you're comparing apples with apples, if you like, when you want to put a firewall in place. I'm not saying I've got to put all this other infrastructure in place, and I put an optical switch in place. Do I have to buy all this stuff together? It's now fitted into this open source framework. And in fact, that will enable more competitors to come along with proprietary software to compete with the incumbents, because there's a level playing field. And that, as much as anything else, is what open source delivers in this.
Gentlemen, we are out of time. Thoroughly enjoyable, good fun, as I expected. Thank you both very much indeed.
It's a pleasure.
Thanks, Martin.
Thank you, Martin.